All right, well, happy Wednesday. Let's take a look real quick. We are halfway through week 2. Again, the schedule's a little weird here with lab being on Monday, but it's okay. It should work out. So we're going to finish out chapter 2, and then we'll talk about your Project 0 assignment. That sound good? All right, so let me start with looking at the lab exercise, because a couple people had just some small issues with their arithmetic. Again, we're not a math class, but making sure we understand what we're doing makes it so we can tell the computer what to do, right? If we just look at it and be like, oh yeah, great, and start typing code away without really understanding what's happening here, we're going to get some bad results, right? And that's okay. You don't need to feel bad if it didn't work well for you here, or if you made mistakes. That's why we're here to learn. It's okay. So I'm going to make a project. I'm putting it in my GitHub repository folder, right? That's my folder here. And this is the public one that'll go out there and everyone can see. For your assignments, you'll get a new folder every time. It's just every time you have to clone it, you'll put your project in it, and then you'll commit and push. It'll get out of the cloud. Helps keep things nice and organized. You don't need one repository per project. It just makes things a little bit more organized, and then you don't have a bunch of different things in the same folder. I don't know. I like doing one per folder, or one assignment, one repository per assignment, and it just works out here. All right, we're going to create our main script here. It's fantastic, and it looks like I'm actually behind. I should go and update my PyCharm. Your version was a little ahead of mine. I'm just going to do mostly the same things. I think that screen you had like one other checkbox there. All right, so lab 0, delete that. Let me zoom in a little bit here. So again, we're doing a couple things here, and we need to calculate. We have to do some arithmetic here. So ask them how many credits are required for the degree, how many credits they've completed. With that, the step that's not here is figuring out how many credits that they have left. Because all this arithmetic needs to be based on how much they have left, right? So that wasn't here. That's implied in solving the problem, right? How many credits you take on average per semester, and then the average credit cost. Again, you could do cost per credit, and you could do a by semester count. I asked for cost per credit, so I think everyone did that. I'll show you both just for fun here. If you wanted to try and see what would the calculation look like if I wanted to take advantage of the block cost thing, sure, we could look at that. Then figure out how many semesters they need to take is another bit of arithmetic, and the total cost is another bit of arithmetic, and displaying those results. Okay, so if we need to get how many credits are required for the degree, we need to make a variable to hold on to that, right? So this is total credits required, and if we're dealing with arithmetic, it's probably going to be a whole number. I don't think anyone ever takes half a credit. Pretty sure. Maybe there's some weird stuff here, but I assume this is going to be an int here. So I'm going to say int, and then in parentheses, whatever I put in here now, Python is going to say, hey, let me try and turn this into an integer. And from there, I want an input. Remember, when we get inputs, the only thing Python knows is it's got to be some text. It's going to be some characters, or a string is our technical term for that. Right? Even if I type in the character 1 and the character 0, it's still text. That's why we're doing this conversion, saying, hey, please try and turn this into an int here. So this is how many total credits are required. Sorry, it gets a little long here, just because I'm zoomed in so far. I can't spell here. Required. Oh, goodness. This is a bad game. All right. So the general rule of thumb when we're writing code is you shouldn't have to scroll left and right to see your code. So because the code that we write is really for people. Right? You want to be able to read it. You want your colleagues to be able to read it. You want me to be able to read it so I can grade you on it, because that's what you care about in this class. In the real world, it'll be your coworkers, and you're going to move on to bigger and better things relatively quickly. So someone else will have to take over for all the projects that you wrote, and if you wrote really crappy and obnoxious code, they're going to hate you, and they're going to curse you all the time. So just don't do that, right? Pretend they're a psychopath. You want to leave them something nice and so that they're happy with you, and they don't want to come after you. It's probably a bad joke, I apologize. But make some nice code. So having to scroll left to right is a big no-no. So eventually it'll even warn you, hey, your line is too long. But for now, that's okay. We can figure that out. Okay, so how many total credits are required? And then this is my credits completed. Same idea here. Now, I don't like to do more work than I need to, so I'm just going to go copy paste this line and paste it in here and just change my text here. Right? If you like to type, go for it. I'm a lazy person. I don't want to have to type more than I want, more than I need to. This is how many credits have you completed? Right? Then we have to do that arithmetic step. Right? You don't have to save it as another variable, but it puts a nice name to what we're doing. Right? One of the reasons we use variables is because it has a name here, and we see, oh, this is the credit you've completed. Right? So this is credits remaining. Credits remaining then is my total credits required minus the credits completed. Again, super basic arithmetic here. You could just always use this bit here in parentheses in every calculation. There's nothing wrong with doing that, right? But because I know I'm going to do it more than once, right? I don't want to have to do this more than one time. It's faster to type this twice than it is to type this twice. Again, I'm lazy, right? That's okay. And then down the road, if we screwed something up, you have to go change it 2 times because you copy pasted it and you did the wrong thing. Because and it's okay if you did. I think one person had them flipped. They said credits completed minus credits required. It's an easy mistake. That's okay. All those things happen all the time, and then we don't have to fix it one place. All right, and then we need to ask how many credits they take on average per semester. So we'll say credits per semester. Again, we'll just paste in our question here where we're converting and change it. How many do you take per semester? Right. Then ask them how much an average credit costs. So cost per credit. Now, if you wanted to have some pennies in here, you could. Maybe we want to call this one a number that can hold decimal places. That's a float value. Sure, I think an int is probably fine here. Again, most of the stuff we're doing here is fine with whole numbers here. So how much does an average credit cost? And now the really annoying thing here too, tuition fees, is not all credits cost the same, even with this block schedule. Because, yeah, good for you. So it says if you take 12 plus credits, that's only $7,620 for the entire semester, except once you get later on in your career. Now you get to start paying more. Here at CIS, we charge you an extra $125 a credit hour for 300 and 400 level classes. Sure. COB charges even more. We love our business friends. They charge you even more money. Castle and CEH, I thought it was chess, but sounds a little bit, is that wrong? Is it CEHHS?
I remember it was chess, it wasn't CEH.
Yeah, I thought it was chess. Okay, whatever. That's our education and health and human services, right? So all 300, 400 level classes are charging you more, just depends on the college here, right? In addition to that, anyway, so whatever. So if we wanted to figure out what, if you only took 12 credits was here, right? So 7620 divided by 12, $635 per credit, if you only take 12. So I might call that my average cost per credit. And I think I just threw out 1,000 because it makes math easy. Because it's really easy to know, hey, if I had 100 credits left and I had to pay $1,000 a credit, that's $100,000. It's a really depressing number, by the way. I'm so sorry for you guys. I'm an old person, but not that old. College wasn't that expensive. Is it really 20 years ago? Not even 20 years ago. No. I graduated in 08 and then 11 with my master's. It was only 13 years ago when I got my master's. And my master's didn't even cost this much per credit. Sorry. Anyway, we'll just be sad. So I'm just going to leave a note in here too, just for fun. So block 12, it's average. Nope. What did we say here? 635. Just for my own fun here, so I'll know what I want to plug in later. But this will work for any school, right? You can go look at them and say, hey, how much does tuition cost somewhere else? Right? It gets worse, by the way, in case you were curious. What was it? Arts Tech per credit. I can't spell, but hopefully I figured out what I meant here. Lawrence Tech, just down the road here, not too far from us. Tuition and fee schedule. Why is this another page here? Tuition and fee schedule. Freshman courses. $1,400 a credit, $1,445, $1,445, $1,445. Graduate is like the same? That's crazy. Okay. Anyway, so it does get worse. That's more than double. But I'm going off on too many tangents. I apologize. All right, so cost per credit. Now we can calculate all the things we need to calculate, right? So my semesters left. Again, you don't have to save it as a variable semesters left, but we can. It'll make my life easy to have a variable name here. I can just drop this in later. And then I know exactly what that calculation means. I don't just in a print statement have some sort of arithmetic, have an expression that I know what it means because I just wrote it, but an hour later, probably will still remember. The next day, there's no way I'm going to remember why I wrote that, right? Let's just be honest. By tomorrow, I'll have no idea. So I think it's easier to put stuff as variables, so we have a name for it. That's one of the reasons we use variables. We put names to things. So this will be my credits remaining divided by my credits per semester, right? If I've got 100 credits left and I take 12 per semester, whatever that happens to be is how many semesters I have left, right? And then my total cost then is going to be my credits remaining times the cost per credit, right? I have to pay for this many more credits. It costs this much per credit. Here we go. That's not even to mention it goes up every year. That's a whole other story. Right, and then I can print it out. So I can print you have, and then we just comma separate the things we want to print here, right? I just throw in some commas and just start putting stuff in here. It's going to automatically add the spaces for me, which is nice. So we'll say semesters left. Now this is the variable, so it's not in quotes, right? It's not just some characters I want to spit out here. It's, hey Python, go get the value that you put here, right? Go find wherever it is in memory. I don't care where you stored it here. Go get the value that we calculated and spit it out for me here. Semesters left. And we can do one more. Right? You can do it all in one line. You can do it on separate lines. There's not a right way or a wrong way here. That's really just a style preference. If you are so bored, I think it's HCI, right? Yeah, we've got a program in human-centered design and engineering. So looking at user experience, UX, you can get a whole master's program in how the right way to make people talk to computers or machines or whatever you want here. Super interesting, like really useful. Turns out the infotainment systems in cars are horrible. Like you shouldn't take your eyes off the road for more than, what are they, like a second? Otherwise it like doubles your chance of an accident. And infotainment systems, you have to press like 3 buttons to do anything you want. It's insane, and we know it. So like infotainment systems are literally killing people. Like, it's not even funny. They're like actually killing people because they're so distracting. So if you're interested in this, please go do good things, right? Keep us all safer. I can't wait till cars drive themselves. My wife won't get in one. She refuses. But I am a better driver than self-driving cars. I'm obviously. The rest of you all suck, right? Self-driving cars are way better than you. So I will trust other people in self-driving cars much more than I trust other actual people, right? So, I mean, it's illegal to hold your phone now in a car. Just, you don't even have to, like, you're not going to be on video, but raise your hand if you are still texting on your phone while driving. Really? Okay. I mean, usually when I'm stopped, right? But that's still wrong at this point. Okay. All right. I guess I'm just a terrible person. My apologies. That was surprising. Okay. And then, so the estimated cost then of, and this will be our total cost. And really, there's probably nothing after that, so maybe I'll just put a dollar sign to make that look a little bit prettier here. Okay, should we give it a try? Let's give it a run. So if there's 120 credits required, and we've completed 20, that means there's 100 left, right? That should be pretty quick. And if we take, if we do, 15, that like comes out to 90 plus one more, right? That's 6 and something semesters left. Okay, so 15 credits per semester, sure. And then average credit, so that'll bring 635 down a little bit, right? If we wanted to do that, that's so 7620 divided by 15. That's only 508 a credit. Look at that, we're saving money now. So yeah, 6 and something, some change semesters left. Estimated cost of 50,000 when we're doing it that way. I think those numbers check out. And again, when we write a program, to know if it's actually correct, we have to know what it's supposed to do. Right? That's why I pull up my calculator here. Right? I have no way of knowing if it's right if I don't know what it was supposed to do, and I can't do that calculation myself, whether or not it's on paper or on a calculator, or even in Excel, because Excel is an awesome tool. Right? We need to make sure that it is correct. because we have to know what it was supposed to do, right? Just writing the code and be like, oh yeah, sure, it gave me some numbers here. Some of you got some wrong numbers your first run, right? And that's okay, right? That's why we run it and test it. It's the process of debugging. So really old people, my father, they used to program on note cards. It was insane, really smart people came up with it because that's the best they had. And you literally like encoded instructions in holes in a note card. It was insane. And you'd feed them into a machine, and the machine would like read these note cards. I don't know why, I wasn't there. But if it didn't do the right thing, we called that a bug, because an actual bug landed on someone's note card and then the machine didn't read it right. So if you go look it up, there's like a picture of note card programming bug. I think it's in here somewhere. I got a maybe history. I forget what it was here. History of programming term bug. Discovered a moth causing a malfunction in the Harvard Mark II computer. Believed to be the first term bug used to describe a glitch in a computer system in 1947. Man.
That's a long time.
That is. I didn't even know they had computers that long ago. Like, I gotta be honest. Holy cow. Wow. Yeah, that's a long time ago. So, okay, I guess I don't think we would think of them the same way we do with modern computers. It's something similar, a computing device. But yeah, that's why we call them bugs, because an actual moth got in there. But, so if something goes wrong with your program, we call it a bug. There's a bug in the program, right? So to debug is to remove the bugs, to get rid of the bugs, to make it do what it's supposed to do. So if you don't give the right numbers out, you have to go debug it and figure out why it's wrong. Right? The cool thing with a good tool like PyCharm, and most programming tools let us do this sort of thing, they're integrated development environments. They have a tool called a debugger. So we didn't get into this yet. This is new stuff just for fun. You can come over to these line numbers here, and notice if I hover over the line number, it like shows up a little red circle, but only on lines that have code on them, right? 3, there's nothing here, but 4, nothing 5, 6, nothing 7, nothing 8, 9, right? 8 doesn't count because that's a comment. Python ignores it here. But you can put, this is called a breakpoint. You click on it, now it's a bright red dot. You click on it, it goes away. Click on it, it shows up here. Instead of run, if you click this little bug icon, it's going to run the program in debug mode. What this lets us do is tell Python to please wait. Get to wherever you are, and when you get to this breakpoint, pause for me. And we can actually see what's happening kind of on the inside. We can see the guts of the program here. So it's how many threads are required, 120. We've completed 20 of them. And now we get a different view here. So we were on the console view over here. Now we're in the threads and variables view here. So that I can see, here's a list of all of my variables and what their values are. So we can see what's being calculated here. Okay, now my credits remaining is 100. So as I'm working through my program, I can see what it's saving in memory for every variable. So if it's not calculating something right, I can see, well, what went wrong where, right? And then the next cool thing you can do is you can run it line by line by line. So we have a couple arrows here that do a bunch of cool stuff here. Most of the time we're going to use this first one, that's step over. It's an up and down arrow. It says, okay, just run that line. Step over, run this line, and then go to the, and then pause. Run the line and pause. Run the line and pause. You got step in, you got step out. Those won't make any sense now, don't worry about it. When we get there, they'll make more sense. But for now, we're just gonna step over, and it runs that line. Okay, so now it says how many credits do you take per semester? Well, you take 15. Great. The next line, then we wanna step over. We want it to run. Remember, nothing was showing there until I told it to run. It will wait at the next line until I tell it to run. It just sits there paused for me. It behaves pretty nicely. So, I don't know, 635, we'll just go back to that number here because I forget what the other one was here. And then we can step over. Now, I'm not viewing the variables, so if I want to go back to threads and variables here, I can see, oh, okay, that's 6.66 whatever semesters left. Sure. And then I can step over, and now we get total cost, and 63550, 500. If you want here, can I thought I could change that. Does it not let me change it? Okay. Never mind. We can't. Set value. So if I right-click on it, I can set the value, and I can change what's here. I'll say, hey, we just gave you a scholarship. If only it was that easy. I mean, it sort of is if you hack the system, but I don't recommend that for you. And now it says, hey, estimated cost is $0. You can change the value stored while it's running. That's not very useful because when you actually run it, it won't do that. But this is for debugging purposes if you want to screw with it and change different values here. Or if you notice, hey, I calculated something wrong, you got lots of options. So we can actually pause the running program and run it line by line by line by line. Or it'll run to the next breakpoint, right? So if I want to pause here and then maybe want to pause here. So pausing on the inputs is not very interesting. Pausing on the calculations is probably more interesting for me. So I'm going to do it one more time here. I'll say 120, 20 credits. It pauses here. Great, so I can step if I want, or I can use the continue. The resume just says go to the next breakpoint. Just keep running like normal here. Right? Okay, so we take 15 credits per semester, 635, and now it gets to the next breakpoint and it's paused again here. So now I can come back and I can see all my values again. So you've got options when you use the debugger to do these things. This is going to be your best friend because you can see step by step by step what's happening behind the scenes. Now, what some people do, and it's okay, we didn't always used to have all these really cool debugger tools. So some people would do what we call the poor man's debugger. And every time they calculate a variable, they would add a print statement and say credits remaining, and then credits remaining. Right? This is poor man's debugging. And then later when they want to run their program, they just comment it out and say, okay, don't actually do this thing. That's okay. There's no shame in doing it that way. But again, I'm lazy. I don't want to have to type something and then tell Python to ignore it. I'd rather just put it into debug mode. But some people like seeing all those values as they're calculating. There's nothing wrong with that. That's fine. And again, I don't really care what the output looks like as long as you've included what I've asked for. If you want to throw more things out on the screen, that's fine. Like for your purposes, doesn't matter, right? I'm not testing you on did you get pretty looking output, right? We're in an intro to programming class as mostly freshmen. I'm sorry if you're not a freshman. Maybe I should stop saying that. We're in an intro to programming class, right? Output doesn't have to look pretty, right? People have been doing this for years and years and years. Can worry about making it look pretty, or people in like a user experience class, user design class, that sort of thing. They can worry about making it pretty. I just want it to work. Right? The end of the day, the goal is you all know how to write code that works. Right? Not just write code, but write code that works. Right? And why I think software is so interesting is because that's really a creative process. As much as we like to call this computer science, and there is some science behind it, the creative part is taking a problem that is complex, because real world problems are hard. Right? I mean, even this semester calculator is relatively basic. There's just a couple steps here, but again, this was week 1. Or week 1.5, right? Start of week 2. You can see there's a bunch of steps, and we have to understand what each step is doing here. So we have to understand the problem well enough to break it down into smaller and smaller and smaller steps to tell the stupid computer what to do. Because the computer will do exactly what we tell it to do, and if we tell it to do the wrong thing, it will happily do the wrong thing, right? If we flip a multiplication and a division sign by mistake here, great, now we just gave everyone a crazy discount here. And now the college is going to fire us because it didn't charge students enough and it didn't have enough money to do all these things, and we'd have to dip into our $15 billion endowment and we'd be fine. But we'd still get fired, right, if we screwed up. That sort of thing here. Where's 18 billion? Isn't it like 18 now? Size of University of Michigan. Endowment. I can't type here. Almost 18 billion, I'm sorry. Just shy of 18 billion in the endowment here. But we definitely need your tuition dollars. It's not enough, honestly, to run just off of that. But okay, never. I'm getting all worked up here. I'm sorry. Okay, so that was sort of the lab idea here. And then again, once we're done, go back to the GitHub desktop. If we put it in the right folder, GitHub says, "Hey, you got new stuff here." If we didn't put it in the folder, Git says, nothing changed in my folder. Right? That's all Git's job is what changed in this folder. A repository is just a folder that Git watches. It's really good at its job here. And then there's actually, if you have your hidden files turned on here, by default, hidden files are hidden here because most people shouldn't mess with them here. But if you go to your view options here, your options and say I want to view hidden files. Right? This is the show hidden file, do not show hidden files versus show hidden files. Usually we want to show hidden files because as developers, we like to see all these things. They're interesting files here. You'll see there's a folder called .git. If a folder has a .git folder inside of it, it's probably a Git repository. Don't ever touch this folder. Right? If you mess with this folder, Git can't work because it keeps all the stuff that it does in this magic folder. And honestly, I don't even know how Git works. I don't really care how it works. Right? I'm not that interested in it. I just know that it works and it's cool. But if you're curious, you can go look up the Git source control tool and do all the sorts of stuff. But everything is inside of here. Sure, these are interesting files. Don't touch them, right? But they're out here. So, but you never see them here. Right? They don't get added to the repository automatically, right? You don't have to worry about that. Now, you'll notice there's a .idea folder. If it starts with a dot, it's supposed to be a hidden folder, right? We're not supposed to mess with it. So inside of Lab 0, there's a .idea folder. Just don't touch anything in there. If it changes, it changes, because that's something that PyCharm is changing for us here. And you can actually look at them and see, hey, here's a profile page, here's an IML page, here's a miscellaneous page. It's using Python 3.12, sure. Right? Here's the modules I'm using, sure. Here's my VCS, whatever. But now there's a main PY file, so just let them all go there. Right? They're all getting here, that's good for you. If I see my code that I expect here, life is good. That's my first check. If it sees the code and the code looks like what I expect, I got the right file, it's in the right folder, I can give it a commit here. So lab 0 done, commit. And again, now my copy of the repository knows about it here, but the cloud doesn't. The next step is to tell the cloud. I have to push to go synchronize with the cloud, right? It's not an automatic sync. It's not like your Google Docs or your OneDrive that syncs automatically for you. It's you commit and then you have to push. Now, if you just pause to think about why we'd want this to be a manual process for a minute, if you're working on a project with a bunch of people on it, and you've got a team of like 7 people all working on some code, do you want the code to change right in front of your eyes? Or do you want to change when you want it to change, when you're ready for it to change? Probably when you're ready for it, right? It'd be really annoying for it to like just like working in a shared Google Doc for it to start changing on you when you're trying to run code. Right? That might be a fun exercise, trying to get 30 people to write code in a Google Doc. It won't work very well. Yeah.
Is it possible to commit and push from PyCharm, or do we have
Yes, yeah. So PyCharm has Git integrations right from commit, and you can do all sorts of cool things.
Okay.
I just like using the GitHub desktop because it's the same for every language I teach, and I teach a bunch of different languages, and then I think the interface is more friendly as well, right? I think it's more clear about what's happening. If you like doing it in PyCharm, go for it, right? Go nuts. It will do the exact same thing. You just have different buttons to click.
And then is it also possible to clone a repository from PyCharm?
There's,
Because I tried to do that and it wouldn't let me.
so if you go to new, there's a way to do it here. I would just go Google how to clone a repository from PyCharm. It would probably tell you. Yeah, again, I either use this tool. I do stuff for the command line as well. So there's like 7 different ways to do everything, whatever option you like. Yeah. All right, we okay with the lab? That made sense? So if you ever want to go look at it, it's out there. Again, I think everyone got it done because everybody left before the time was up for the lab. So I'm assuming everyone got it done and turned it in here. I didn't actually go look yet, but only 20 got graded, or only got submitted. I thought we had more than 20 people in the class. That's fine. I can look it up later. But if you,
there was 23 students.
that's what I thought. It might have changed. That was last week, so it might have scared some people off because I'm crazy. That's okay. That happens. All right, so let's go back to our Zybook here. Oh, let's see how many people signed up for the Zybook now. 19. Okay, we're getting good now. We're getting close. So floating point numbers. Do we get to floating point numbers yet? Numbers with decimal places. All right, numbers with decimal places. Fantastic. Let me go open up my recent projects. There we go. Here's chapter 2. All right, so in chapter 2, this is where we kind of left off here. I'm just going to do it at the top here. Otherwise, when I hit run, everything's going to be at the bottom. I can make a new project, but I'm feeling a little lazy here. So when we did our arithmetic, like 1 divided by 3, we got a numbers with decimal places, right? A number with decimal places in Python we call floating point numbers. I don't know why, that's what we call them here. So I can have values here, like some, yeah.
Sorry, really quick, how did you get from the Zybooks pop up into question?
Oh, I just flipped between the two.
Oh.
Yeah. I just have them both open. There's no direct link between the two.
Okay. I thought that, I literally thought I saw you switch them. Oh.
I think I just clicked between the two. sometimes I use other shortcuts like Alt-Tab. You can flip between your windows. Okay. No, sorry. This was our work from chapter 2, just from Monday. So I had that repository. So some number with decimals, like 4.2. Sure, we can have a number with decimal places now. Python can also do that. Now, you have to be a little bit careful when you're doing arithmetic with decimal places, because occasionally it screws up the like the very last digit, because computers are actually bad at this sort of thing, and that's why we don't recommend this for banking. But if something changes in your 15th decimal place, it probably doesn't matter much, but sometimes you can get some weird results. For our purposes, we're not going to care. Just keep that in your back pocket for later. So that's our floating point number. It's a number with a decimal place, right? That's all it is. Nothing super fancy for those. If you want to do to the power of, right, this is our exponent operator, right? Multiply. You can see what really big numbers are. Eventually, they get too big here, right? So this is showing you if you were to copy paste these 3 lines in here, weird stuff is going to happen, right? And we get result too large. Remember, everything gets stored eventually in bits and bytes. I spent way too much time talking about bytes because they entertain me here, right? And we've got billions of bytes of memory. Just because the computer has that much memory doesn't mean Python can store an individual variable in a certain amount of space, right? There's a max size that Python can use to store floating point numbers, and turns out 2 to the 1024 is too big for it here. It can hold 154 decimal places, or no, to the left of the decimal, right? So 154 digits it can hold. Whatever this number is, it's really big. That's too big. I don't know at what point it dies on you here, but eventually they get too big, right? Because it can only store so much information, because my floating point values only have so many bytes, right? We looked at how many bytes we got here thanks to the power of 2. We played, had some fun with it. It was a bunch of numbers. What was it here? It was a bunch of numbers, right? Programming calculator on bit flipping to the 64 here. So this was only 9 quintillion, centillion, I forget here. This is not even close to 154 digits, right? So we're using more than 1, 2, 3, 4, 5, 8 bytes here for a float, right? We're using a good amount of space here, but eventually we run out of space. That's all. And you'll get these overflow errors. We will probably never do a calculation that overflows for what we're going to do in class here. But eventually, bad things happen, the program crashes, and we all get sad. Right? And it tells you, oh, this is what went wrong here. It was too large. So those are fun. Yeah, MathPy, sure. If you want, you get formatted. We don't really talk about formatted strings till later, but they're giving you a quick little hint here. If you only want so many digits of pi here, you can use, this is called an F string, a formatted string. I don't know why they show this now, but that's okay. Here's the value, and then we want 4 decimal places of a floating point value. We'll talk more about this when we get there, and this will make more sense. But you can do specific formatting if you're so curious. I'm going to comment that one out so it doesn't crash on us here. But now we get pi to 4 decimal places. Right. That's all. So you can do some fun stuff with that. You don't have to show all of them every single time. Some people's eyes roll into the back of their head after 3 decimal places because they get scared of numbers. I blame elementary school math teachers for people being scared of numbers, but that's okay. It's probably the education system too. All right, so that one was good. Let's go back. We did some arithmetic expressions, Python expressions. Let's take a look at this one here. Yeah, so that's fine. Operators, compound operators. So because programmers are lazy, right? If we wanted to do something and say, hey, I want to add some value to this. I want to say some number of decimals. Now, if I want to change that value, I can say it equals some number of decimals plus 2. Everything gets evaluated from right to left. So Python says, okay, what is the value of this? And it goes out and gets 4.2, and it adds 2 to that. Now I have 6.2, and then it gets assigned to the value on the left. So now we've updated it from 4.2 to 6.2, right? Because this thing on the right happens, and then it gets stored to the variable on the left. Because this is a lot of typing here, we've got some shortcuts. If I want to add something to it, I can say plus equals 2. This is the combined assignment operator. It says do this assignment, or I'm sorry, do this operator, and then assign. Now the downside is if you're not careful here, you can also say equals plus 2 here. What do you think is going to happen after this line runs? Think back to our order of operations. And here's a hint. This is positive 2. It's not going to add anything. I get positive 2, and then it says, okay, I've evaluated the thing on the right. You want 2, positive 2. It says, okay, you want to assign that to some number with decimals. Now I've screwed up and I just have 2. Right? I didn't add anything to it here, so you want to be careful with the order. So it's operator first, and then assignment. Right? They both work, which is nuts here for at least the plus. Yeah.
Is that applicable with any operator?
No. So thankfully, like saying some number with decimals equals divided 2, it's like I don't know what a divide by 2 is.
What about before the equal sign?
Oh yeah. So you can do all the operators as combined assignment operators. Yeah. So you can go through plus equals, minus equals, times equals, divide equals, modulus equals, which is nuts here because that's the next one. I didn't write the books. I'm sorry. I don't know why they're nuts sometimes here. But we'll get to what that. Yeah, operator discussed elsewhere. Okay. I guess I should read better here. All right. So think back to 3rd grade math class when you start learning long division, right? We say, what's 10 divided by 3? Okay, well, let me count by 3s. 3, 6, 9, 12. Oh, 12 is too big, so 9. And then what's the remainder? So our answer would be 3 remainder 1. You guys don't look impressed that I can do math. It's okay. So if you want to get a remainder out, we have a special operator for that called modulus. That's the percent sign. So we can say, here's our answer, our remainder, then is going to be, let's ask the user. Let's be more fun here. So we'll ask the user to enter a number. So we'll say first number is, and let's say a float. We'll say a float of an input here. I don't know what they're going to give me here, but we'll assume there's something here, right? Enter first number, and we'll do the same for second number. So we'll make another variable. I'm just going to copy here and change a couple things, because again, I don't like typing. If you double-click something, by the way, it'll highlight the entire word. I can quickly grab that and then start typing over it to replace. You don't need to go and backspace it here. You can just double click and then start typing something and it gets replaced. That's a fun shortcut. I'm changing my mind here. I'm sorry. I want these as ints. Floats aren't going to do what I want here. Sorry. So then we can do some arithmetic. So my you have a divisor. You have the dividend. Man, 3rd grade math class was a long time ago. I know what the remainder is here, but the answer. Result of division of?
The quotient?
Quotient. Is it quotient? Quotient. Hey, okay, didn't tell me I spelled it wrong.
I think there's an S or maybe a C in there somewhere.
Are you messing with me?
I'm dyslexic.
Okay.
Spelling is not my department.
No, not mine either. Mine either. That's why I'm glad this one has spell check. So we'll call this quotient. That's probably close enough. So it'll be my first number divided by the second number. And what I want is this as an integer. So I'm going to say int of this. Right? I don't want a decimal place. And what int's going to do is if there's a decimal place, it's going to get rid of it. Just whack it. It's not going to round anything at all, which is perfect for our purposes. So if it's 4.9999999 and I say I want an int of 4.99999, I get 4. Right? Which is perfect for this, right? I get a whole number. Then my remainder.
Is that why you didn't put a float, so it's not a decimal?
Yeah, it was going to mess me up later. Yeah, so now my remainder then is going to be my first number modulus the second number. So it does the division and gives you the whole integer remainder here, right? So is modulus gives the whole number or integer remainder of division. Okay, and then we can print those out here. First number, comma, divided by, second number, comma, is equal to, we'll use the single equal sign. We know that's the assignment operator, but everyone in math land is going to complain. And that'll be my quotient, comma, remainder, and then the remainder. This is a long, ugly print here, but that'll be okay. We'll make it work here. So let me just pull that over a little bit. All right, let's give it a run, see if that works for us. So first number, should we try 10 divided by 3? That's my first example. 10 divided by 3 equals 3 remainder 1. Are you impressed it does math? I'm impressed sometimes it does math. Right. So doesn't sound like it'd be all that useful, but there are certain times the modulus is really helpful, really handy here. Doesn't help a whole lot till we get to the next, our branching chapter. Then we'll really start to be useful here once we start doing branching stuff. Because now I'll be able to do something like, hey, is it evenly divisible by? So if a number is evenly divisible, there's no remainder, so the result of the modulus should be 0. And I can check, hey, is the result of the modulus 0 or not? Pretty quickly, right? All right. Here's doing division and modulo. So module basics, we imported math already. What else do we? Yeah, this is just telling you more about how modules work here. Don't worry too much about that one. Read it, go through the exercise. I'm not going to spend much time on it. That's a whole topic later. We get into a whole chapter on modules. That's just like a little intro to it here. So the math module does all sorts of cool math stuff, right? Common ones in the math module. Seal is short for ceiling, means round up, right? There's like the arrows, the little hats or something. I forget what they're called here. Yeah, step. So I forget the symbols. But yeah, factorial. You can do factorials. You can get the remainder of the division. You can use fmod versus the modulus operator. Sure, if you want. You can do exponents. You can do powers. And if you like using the math module versus using our built-in operators, you can do that too. That's fine. You've got fabs. Long story with this one, but this is absolute value here with an F. I think because this one supports floating point numbers, I forget here. There's a long story. It's not all that interesting here. But fabs, not just abs for absolute value here. Floor, rounding down. Sum of a range, list, or array. We don't know what those are yet until we get to the next chapter. Don't worry about it, but it can sum things for you pretty quick. Square root, the log of something. And then if you like trig, or if you don't like trig and want Python to do the trig for you here, basically anything you want in trig it can do as well. Complex numbers. I don't even know what a gamma function is, to be honest. But sure, go for it. Have fun with that. Or some constants like pi or e we've got. We did pi before, and you can play with some of those, which is fun. Hey, look, how do we compute this? Well, we're probably going to need the square root function, right? Make sure we do some order of operations. So you'll have a chance to practice those, which is fun. That's the math module. Random numbers is one of my favorite things here, because random numbers make things more interesting. Every time I run my program, I'm going to get a different number back out here. So if you want just a random value, you can get a random number. Now, what's weird about random, and it will make a little bit more sense as we work with it more, is when you call random. So we have to import random. So we'll say I want to import random. Again, telling Python, hey, let me use this code here. It's not being used by default. You can sort of think of an import as saying, go find this thing and copy paste it at the top. Right? So I don't have to copy paste it myself. I could go out there and do it myself if I wanted. I can just tell Python, hey, import this code. And it basically puts it at the top. It's a little bit more complex than that, but for our purposes, that's close enough for now. Now, if I want to use it, I'll say random dot. If I put a dot after random, now I get to see all the cool things I get out of random. A bunch of weird things in here. Randint is a pretty easy one we can use. So randint, and I give it a set of parentheses. It says, give me A and give me B. Not the most interesting here, but I can say 1 and 10. Sure, it's not the most helpful. But randint 1 to 10 here, and I'm just going to copy paste this a bunch of times here for fun. There's better ways to do this, I promise. We just haven't got there yet, so copy paste will do for now. I forgot print. I wanted to print a random number. Just generating a random number doesn't do anything for me. This is why copy pasting the wrong thing is obnoxious. So I have to go fix it now. Sure, there we go. There's a bunch. Let's try that. Now we get some numbers, right? They're probably pretty random. 3, 2, 6, 9, 1, 3, 2, 4, whatever. So you see between 1 and 10. So I put in 1 as the start, 10 as the end. We're kind of just figuring that out as we look at our results we get back out. So we saw a 1, we saw a 10. And if I run it again here, I'm going to get a different order. It's not going to be 3, 2, 6, 9. We stop and run. Stop and run again. Now we get 10, 8, 5, 6, right? A different sequence. And if I do it again, I'll get another different sequence. 8, 8, 1, on and on and on and on. So you'll get different sets of random numbers here. Now, just as a fair warning, this random number generator here, we're going to call pseudo-random. It looks like it's random, but it's not really random because there's code behind the scenes that if someone knows what they're doing, can actually predict what numbers we're going to generate here. This is not a cryptographically secure random number generator. So don't use this for doing anything that has to deal with cryptography. When you get there eventually, they'll tell you that anyway. But that you can use cryptographically secure random number generators if you want to do anything like that. I never took any cryptography classes, thankfully. My buddy who took one told me the first rule in cryptography is don't do your own cryptography. Right? There's literally like dozens and dozens, probably hundreds, if not more, people with PhDs who study and research this stuff and write cryptographic algorithms for people to use. And they've been peer-reviewed and looked at, and other smart people have agreed these are safe to use. If you think you can do better, let's just admit we're probably not going to, right? The odds of us doing better than an army of PhDs is really, really low. If you go out and get a PhD in cryptography, then you got a chance here. But us as undergrads, I got a master's degree, no, not even going to try, right? Not worth it. But pseudo-random, it's mostly random. And there's ways to mess with it as well. We can take a look at those in a little while here. But random, without randint, gives you a floating point number between 0 up to but not including 1. Sure, so you'll never get a 1 out. You'll always be something start. You could get a 0, but you're never going to get a 1. So you get a floating point random number here. So randint is probably the easiest way to get random integers here. If you want random floats, well, sure, just take random and multiply by something, right? You'll get some results. So if you want a floating point number between, say, 1 and 100 here, print random.random times 100, right? I'm never going to get 100 here, but it's possible I'll get 0. So if I wanted between 1 and 100, then I would add 1, right? Because random never gives a 1. I can't even spell because. There we go. If I want 1 to 100, I add 1. Hopefully that part makes sense, right? Because this will only ever be 0 to 99. It'll never hit the top number. I'm going to add 1 to offset it, to make it 1 to 100, as a floating point number here. And we'll get some crazy results here. We could run this for a really long time and never find this same number again here, right? Those floating point numbers with 15 decimal places, that's a big number. Okay, so we can do floats. You can do random range if you want. There's a couple different options, different ways of doing it here. Randint, I like min and max. This works out pretty well here. Now it's weird that it is inclusive of the max. Rand range is exclusive of the match, thanks to the fine folks at Python screwing with us. Just go look it up. Right? You don't have to keep that tidbit in your head, but one of them includes the endpoint, one of them does not include the endpoint. Yeah, cool. Yes, okay, so because this is pseudo-random, you can give it a seed value. So essentially what happens is you give it a number to start with. That's called our seed. That number is used to generate random numbers. To make it look like it's random, most of the time when our program runs, it gets seeded with clock time, whatever the time is in our computer. Because you're never going to run the same program at the exact same time, it's going to look like it's a different set of random numbers every time. Right? That's a quick, easy way for it to give it a random seed. But if we want to get a specific sequence of random numbers, we can go put in a seed here. So we can say random.seed, and it doesn't really matter what we give it here. We'll go 15 because that's what the book had, right? If I give it 15, now I get 4191. And I run it again, and I get 4191. And I run it again, and I get 4191. Because I've fixed this seed value and it's pseudo-random, I'll get the exact same sequence of random numbers out every time I run my program, because it started with the exact same seed. So this is not very useful for us in a program where we want things to be random. But if we want it to be consistently random, for reasons, right, whatever, sure, we can do that. This will make things a little bit easier to test later on. Like if we wanted to build a slot machine game, it's really hard to test getting a jackpot. But if you can fix a seed, it's a little bit easier to get a jackpot in your slot machine game, because you know what the numbers are going to come out as, right? That sort of thing. So this fixes the pseudo-random sequence. Did I spell pseudo wrong? I did. U-D-O, pseudo. There we go. All right, I'll get one of these days, maybe. I'll get it. So it gives you some control over this being random or not here, or how random it's going to be here. All right, and then text, the last one here. We're cruising, we're doing it. We got a little bit of time left. Fun fact about characters is, remember everything gets stored as bits and bytes? There's no letter A in memory. There's no letter B, there's bits and bytes. They're on and off here. So everything that is a character gets stored in what we'll call Unicode. Right? It's a code for our characters. So each character has a specific decimal value that represents it. So when I store the letter A, it's capital A here, it's actually storing the number 65. And Python knows, oh, when I'm looking for characters and I see 65, I'm going to translate that to an A. It just goes and does a lookup for us, essentially. Little a, lowercase a, is 97. It's not worth remembering. You can just go look this up here. But any character has a corresponding code in the Unicode table. And we can go look all these things up here. So if you just look up Unicode table. What's fun is you can get interesting characters you don't usually see, right? Because we can code them in as numbers. So sure, the H hat, small Latin small h with a circumflex, not a hat, sorry. That was not our technical term, is 125. Sure, so any character we want here, we can represent in Unicode, essentially, which is really cool. At some point, we can't actually spit these things back out because the console doesn't know about them. I forget at what point and which versions they're compatible with. But we really care about the lower ones here. Those are the more interesting ones, right? What is an A here? What is a B? So on and so on and so on. Now, we can convert between numbers and characters and numbers. If you're so curious, we can do that sort of thing. But one other fun fact, because storing certain characters is weird as in strings here, we're going to use these escape sequences. So if you wanted to print out and have the new line character, you put a \n. So because that is one of these characters here in Unicode, it says, hey, go down a line, right? The new line says go to the next line here. We have to put that in a certain way. So the \/ in a bunch of text in a string is the keyword to say, hey, the next thing after me is special. So if you want to be able to have quotes here and say, I want to print, say like someone's name is O'Connor, there's an apostrophe here in that, right? And I'm using double quotes in my text. But now if I said O'Connor said, and like if I'm writing a story here, hi Eric, and I try and put in some quotes, I get some weird results, right? Because Python says, oh, you stopped your string here. I see the first quote, I see the ending quote, you must be done with your string. So to get a quote to spit out here, I have to escape it. I have to tell Python, hey, I want a special character. So I put a \, in, and it says, oh, the thing that comes after you must be special. And now I still get some red lines because I also need to escape this next one here. So \, quote, inside of a string will actually give you the quote character. Because otherwise it's like, oh, you probably wanted to end your string. Now, if you're just writing something here and you also don't have apostrophes, like if I wanted to talk to Jeb, so Eric said hi to Jeb, if I use single quotes here, my apostrophes here, I can put double quotes inside without having to escape them. but sometimes you have to use the double quotes because you're doing single quotes inside, or you can mix and match. You could do the other way around. We could do single quotes on the outside here, and then we'd have to escape our single quote here. Here's that one. There we go. This is a bunch of nonsense here, right? But whatever you're using on the outside, you're going to have to escape on the inside, because otherwise it thinks you ended the string here. So if I'm using single quotes, if I want a apostrophe to show, I have to escape it with the backslash. If I'm using my full quotes and I want a quote to show, I have to escape it on the inside here. The other fun stuff you can do is you can do those non-visible characters like the new line character, right? So like 1 backslash n, 2 backslash n, 3 backslash n, blast off. Well, that should be 3, 2, 1, shouldn't it? 3, 2, 1, blast off. So the backslash n will put the new line character right in the middle of my string here. So when I print this out here, we get 3, 2, 1 separated by lines. Maybe this is faster than saying print 3, print 2, right? It's just a style preference, really, however you like to do them here. So we can do those if we want. You can also do tabs. Tab that indents, it's like 4 or 5 spaces or something like that. You can use tabs in here, which lets you make like some pretty looking menus or some quotes, or like, hey, I'm going to give you an option and then tab a bunch of stuff in, or if you want your output to look really pretty, you can start using tabs. I'll never use them. It's just too much work for me, it's not worth looking that pretty. But that's me. A raw string is another shortcut we can use that says, hey, I want to ignore escape sequences. I don't know why you'd want to do this, but it's an option. You can get a little nuts here. So you get the normal string here because there's a backslash n. It puts it down a line. If you say it's a raw string by putting the letter R there, it sees a backslash n and says, oh, sure, you want a backslash n. I'm going to treat that as you wrote it, right? I'm not going to do any escaping here. Feels like a lot of work, honestly, to do these sorts of things here. So that one's a little weird, but you can. All right, now back to the top where we talked about characters. So you can convert between numbers and characters. You can say ORD. I want the ordinal value. I don't know why they didn't pick Unicode or something like that, but sure, ORD, the ordinal value. So if you wanted to be fancy, and let's say we're going to write like a secret spy letter here, I can print, I want the ordinal value of E, and print the ordinal value of R, and let me just copy paste this again, I'm getting lazy, E, R, I, and C. So I can encode Eric in my Unicode values, 69, 114, 105, 99. So these are the numeric representations. Then if I wanted to, right, I could say, hey, let's take that and add 1 to it. Let's add 1 to each of these letters here for fun. So if I add 1, right, I get, obviously, those plus 1. Now if I take all of that and I convert back to character with CHR, CHR for character. I don't know why it's CHR, but sure. Right, I'm going to convert those back to character. I've essentially taken my name here and shifted all of the letters by 1. It's a simple, it's not even a substitution cipher. What is that, like a shifting cipher or something? I forget what we call those. There's a technical term for it. I've just shifted all my letters down by 1. Now we get I've encoded Eric. We should not confuse this with encryption. This is not encrypted, just encoded it differently. People who are into encryption will quickly tell you it's not encryption. I enjoy being pedantic because it amuses me sometimes, but so we can quickly shift the letters over 1, right, if I want. Right? So sure, cool, we can do that sort of thing. And we can do it with any sort of input, too, if we wanted, right? It doesn't have to just be Eric here. We could ask someone, hey, enter the first letter, enter the second letter, enter the third letter, and we can do that shifting for them. So whatever letters they give us here, we can shift. So we'll say, how about we'll have first letter is equal to an input of enter the first letter to encode, and then we'll do first and second and third. We'll just do 3 letters for the sake of exercise here. So we can like encode dog and cat and bat and like your phonics readers, right? We can really confuse your kids and encode all of their words to something else. Second letter and third letter. You probably all feel really bad for my kids. That's okay. Second, probably should. And third. All right, so we'll get 3 letters, and then I'm going to go do that shifting here. Right. So should we just add? We can add more than one, or we could ask them. How about that? So I'll have a shift amount. Shift amount is an int of an input. How far should we shift the letters? Great, and I'll enter a value, and then I'll have now my first value is going to be the ordinal value of the first letter plus the shift amount. Right? Grab that character, turn it into its ordinal value. Right? Capital E was 69. Sure. Now let's add a shift amount here. Then I'll get a second value and a third value. I'm just doing the step by step as we go. So the second value and the third value of the second letter. And again, I'm not typing everything. I'm doing a couple letters here, and it suggests third, and I'm hitting tab for it to autocomplete. Right? You don't have to type it all. Right? Let the computer do the work for you. Most of the work for you. Don't let it do all your work. Right? That's a bad habit. Now we get some values, and then I want to print out then the ordinal value, the character representation of the first value. Right? And then we could just, do these all in one line here of the second value, and then the character representation of the third value. Now, if you're not careful though, you might accidentally have, like when you start doing third, you might get letter versus value. So you got to kind of pay attention to what you're doing here, right? If you're just like picking the very first thing every single time, it might lead you bad. It'll do the wrong thing here. So just make sure you're getting what you expect, right? I want the values here that I'm converting here, right? All right. So what's the first letter to encode? What are we going to encode?
F.
F. Okay, second letter.
O.
O. Third letter.
Z.
Z. Faz. Okay, sure. We can, that's fine. And how many letters, or how far should we shift the letters?
5.
By 5, okay. So then our output is, where'd it go? KT, Z plus 5. Didn't work out so well for us.
We changed the Z.
Yeah. So it wasn't able to print that one. Whatever Z plus 5 is, if we go look at the Unicode table, what is little z plus 5? 1, 2, 3, 4, 5. That was the delete key. Delete character. It doesn't know how to print that one, so sorry. Okay, well, so we ran into a problem here. We can fix this, right? If we go too far, then how about we fix it? So we've got our letters, we got the shift amounts here, but I know that I don't want to go past 7. Why is this in hexadecimal? I hate hexadecimal. 7A. It had the table over here. It was easier to use. Little z was 122. I don't want to go past 122, right? Now these are all, if they're all lowercase, let's assume they're all lowercase to make this easy because we only have a couple minutes left here. So if they go further than 122, we've gone too far, right? So I want to subtract, and let me think of this for a second again here. We'll take the letter, so little a should be 97. So if I subtract 97, I'm going to get to 0, right? It'll give me out to 0 for all my lowercase letters. So I'm going to subtract 97 from each of these, minus 97, minus 97, and this is, I'm feeling a little bad here. This is the value of lower a. It's 97, right? Instead of having 97 here, because we're not going to remember what that is next time, we'll take the value of lower a. I'm going to take all of that here then, value of lower a. Ouch, I don't even need my parentheses here, sorry. I was getting too excited. So we're going to subtract the value of lower a, so that now I'm going to have between 0 and 26, right, for each of these values. Then I can have my shift amount here, right? And then if I got greater than 26, what I want to do now is now I want some parentheses. I can say, hey, let's modulus that by 26. So if you had z and you were 26, actually 25, right? 26? One of those values here, right? We're going to flip back to 0 or 1. right? So z plus 5 was going to be 122. Let's see if that checks out here. So 122 minus 97 is 25. Plus 5, then is 30. If we take the modulus of 26 here, right, what's left over after I divide out 26 is 4, right? So A was 0, B was 1, C was 2, D was 3, E was 4. So Z plus 5 is 5 more letters. If we wrap back around here, it gives me 5. It should be pretty good. So we'll take the remainder of that, right? Modulus 26. And then I want to add back in the value of lower a. Mod 26 plus the value of lower a to put me back to where I was before. Mod 26 plus the value of lower a, and I got to add in some more parentheses here. Right? The whole idea here is so that I want to wrap back around, but I don't have a very easy way to say if you go from 122 to go back to 97, the math is hurting my head at the moment. So I'm going to do between 0 and 25. There's my 26 letters here, and then mod 26. If you got to 26, go back to A. If you're past 26, 27 is a 1, 28 is a 2, 29 is a 3, right, on and on and on. Here, we can do this arithmetic here, and that should take care of that for us. Let's give it a try. We got one more minute here. So let's try, we had FOZ, right? F, O, and Z. We have to shift by 5. So I can't do any alphabet, but Z, 5 letters after Z, if we wrap back around, A, B, C, D, E. That one I got. I assume these other ones are probably right here. And then the fun thing is I can say, hey, let's go by F, O, and Z. Let's go like 32. It still works because we're still doing modulus, right? I don't know what it was happened to be here. So we can encode our letters with a simple cipher here. All right, let me put this out on GitHub, and I will see you folks on Monday. Oh, we didn't talk about the project. We'll have to do that next week. Sorry. I got excited. All right. Remind me for next week, Ben.